We will look at RC circuits in this lecture, which contain both a resistor and a capacitor. In this kind of circuits, the current changes with time. An RC circuit is a series combination of a resistor and a capacitor. For the charging process, which is shown on the left, we need a battery as well to charge the capacitor. For the discharging process, which is on the right, we just need capacitor and the resistor. In the charging process, when the switch closed, the capacitor begins to charge. It continues charging until it reaches its maximal charge, at which point the current in the circuit becomes zero. Let's look at the process of charging more closely for RC circuit. The charging process is not instantaneous. The quantity R times C for RC circuit is called time constant. So we call it tau equals R times C. The resistance times capacitance. This is time constant. And the charge on the capacitor follows exponential curve. So it will take time tau for the capacitor to reach 63.2% of its full charge. So that's how the charge on the capacitor as a function of time for this RC circuit. And at the time tau, the charge is just a maximal charge. At the time tau, the capacitor contains 63.2% of the maximal charge. And it will take an infinite long time for the capacitor to be charged to full charge, but it will get really close to this full charge for a fairly reasonable amount of time. The charge on the capacitor is given by this exponential function. So we can verify if t equals 0, this entire thing equals 1. So the charge on the capacitor is 0. When t equals 0, charge on the capacitor is 0. When t equals tau, which is R times C, so it becomes 1 minus exponential minus 1. And if we do the calculation, we'll find that this is exactly equals to 0.632. This is y at time tau. We get 63.2% of the full charge in the charging process. Okay, now that we can have a look at the discharging process. The discharging process, which means the capacitor is fully charged at the time t equals 0. So it's a maximal charge at t equals 0. And then we close the switch at t equals 0. Charges will flow. Current will flow this way. So charges on the capacitor will decrease. So current will decrease as well. And it also follows an exponential function. This time, the charge on the capacitor is given by this exponential function. So we can verify at t equals 0, this exponential 0 should give us 1. So we have full charge at t equals 0. At t equal tau, at t equal tau, the charge on the capacitor is an exponential minus to the power of minus 1 is just roughly 0.368. So at time tau, we have 36.8% of charge left on the capacitor.